Hello. So today's topic is about piecewise function. And to begin with, let us first define what is piecewise function. So it's a function, okay, defined by multiple sub-functions, each applicable to a specific interval of the domain. So given that we have f of x function here, and from this function we have multiple sub-functions. We have f of 1 of x, or f sub 1 of x rather, f sub 2 of x, up to f sub n of x. And each sub-functions here has conditions or interval of the domain. So to evaluate a piecewise function, you must first determine which interval the input value falls into. Okay. For example, you want to evaluate f of -1. So between these conditions, or between this interval, which interval this -1 lies. So in this first, is it in the first condition or in the second condition? So -1 here lies at first condition. Okay, since -1 is less than 0, so we will be using this sub-function, which is -x, right? So that is the step number 2. Then after that, in step number 3, you just substitute, okay, your x value in your sub-functions. Okay, since our x is -1 and -1 is less than 0, so we will be using this -x sub-function. And to evaluate, we have f of -1 equals negative times -x. Okay, I mean, it should be -1 rather here. So negative times -1, and the answer is 1. Okay, positive 1. Next, so if we're going to evaluate f of 0, so f of 0 lies at this second condition. Okay, and since it is applicable in the second condition, so we will use this sub-function, okay, this second sub-function. So to evaluate, so we have f of 0 equals 0 squared plus 1, and we have 1. Okay. Plus, if we're going to evaluate f of 2, for example, we all know that 2 is greater than 0, right? So it is applicable here in the second condition also. So therefore, we will be using this second sub-function. Okay. So f of 2 equals 2 squared plus 1, and we have 5. Okay. So that's how you evaluate a sub-function, a piecewise function rather. And if you're going to graph this, so let's use the traditional method, no? So we have x and y here. We try to set some values of x, and then after that we get the corresponding y values, and these values x and y, okay, will be used for plotting. Okay. And given this f of x, okay, so this is the graph of this piecewise function. Next, let us define an even and odd function. So let's use this illustration so that you can easily know this. Okay. So when we say even function, okay, this function, okay, the graph of this function, we're going to graph this function given that we have y equals x squared. So if you cut it, okay, into 2, so you can see that the graph is symmetrical, right? It mirrored the other side. So this left side is similar to this right side. Okay. However, in add function, if you're going to graph an add function, and then you cut it into two, right? Proportionally, right? So you can see that the graph of an add function, it is also mirrored, but it is rotated 180 degree. So here you can see its behavior of the graph is moving upward, and then this one and the other side it's moving downward. Okay. Its curve is similar, but again it is rotated. It shows an opposite direction. This is, by the way, this is the graph of a function x cubed. So now, how do we know if the given function is an even or odd? So let's proceed here in the given example. Okay. So in order for you to determine if your function is even or odd, you just need to replace your f of x. Given that you have f of x, replace your x by negative x. Okay. So in this example, so we have f of x equals 4x to the fourth minus 3x squared plus 3. Okay. Let's try to solve for f of negative x. So we just replace x by negative x. So we have 4 times negative x to the fourth minus 3 times negative x quantity squared plus 3. So therefore we have 4x to the fourth minus 3x squared plus 3. And as you can see here, your f of x is similar to f of negative x. If that condition is true, therefore your function is even. Okay. It is an even function. Again, if your original function, which is f of x, is equal to your function, which is f of negative x, okay, therefore the given function is an even function. Next. So again, let's solve for f of negative x. Given this function, f of x equals x plus 3x cubed minus x to the fifth. So let's replace x by negative x. So we have negative x plus 3 times negative x quantity cubed minus negative x to the fifth. And therefore we have f of negative x equals negative x minus 3x cubed plus x to the fifth. And as you can see here, okay, it is somehow similar with our original equation or given equation, but each term changes its sign. So we have positive x here, and in this part we have negative x. We have positive 3x cubed here, and then in this term we have negative 3x cubed. We have negative x to the fifth, and we have here positive x to the fifth. So in short, okay, our f of x is equal to the negative f of x. Okay, so if this condition is true, so therefore it is an odd function. So this given example is an odd function. So to make it simple to you, like if each term changes its sign, so therefore that's an odd function. Okay. Next. Okay, wait. So another trick here, right? If if you see, if the given function, okay, by looking at the exponent or degree of each term, okay, wait, okay, so going back here in our example, we have f of x equals 4x to the fourth minus 3x squared plus 3. So each term here, the degree of each term here, we have 4, 2, and then let's say we have 0 here, okay, that's 0. So as you can see, all of the degrees or all of the exponent are even, so therefore this function is an even function. No need to solve, no need to do the or substitute the f of negative x or the negative x in the given function. So that's the trick here. Next, in this part, so in order for you to determine if your function is odd, so just do the same process. If I'll analyze the given term, so we have x here raised to 1, 3x to the 3x cubed, okay, we have 3, and then x to the fifth, we have 5. So each exponent, or all the exponent rather, are odd. So therefore, it is an odd function. Last, so given that we have here f of x equals 2x cubed plus 3x squared minus x plus 3. So let's solve for x. So, let's solve for f of negative x. So replace x by negative x. So we have here 2 minus x, or 2 times negative x quantity cubed plus 3 times negative x quantity squared minus negative x plus 3. So to simplify, so we have negative 2x cubed minus 3x squared plus x plus 3. As you can see here, okay, it is not similar with our original f of x. Right? Also, the sign, okay, we have in original we have positive here, and then we have negative. We have positive here, we have negative. We have negative here, we have positive here, and we have positive here and also positive here. So not all terms, okay. All terms changes its sign except for the 3, right? So therefore, the condition for odd function is not satisfied. If both conditions are not satisfied, so it is neither even nor odd function, right? So the trick here is that, okay, if you're going to analyze each degree or each exponent of the term, so we have 3, 2, 1, and then 0. So it's alternate, right? It has, the given function has, or the given function have even and odd degree or exponent. So therefore, it's neither even nor odd function. So that's how you determine if your odd, even, I mean, if your function is uneven or odd function. Okay. Next, let's proceed. Let's proceed here, operations and functions. So basically, it's just adding functions, subtracting, multiplying, dividing, and some compositions. So these are just let's say basic rule, okay, when it comes to operations and functions. So let's start with addition of function. So given that we have f of x and g of x, okay, those two functions, and if we're going to get the sum of these, so the notation will be f plus g of x equals f of x plus g of x. Okay, for example, we have f of x equals 2x plus 3 and g of x equals x squared. So to solve for f plus g of x, we just simply add those functions, two functions. So we have 2x plus 3 plus x squared. Then the answer would be this one, x squared plus 2x plus 3. Next, subtraction of functions. So given two functions, okay, f of x and g of x. So if we're going to get the difference between two functions, so it is defined as f minus g of x, okay, which is equal to f of x minus g of x. Example again, so we have f of x equals 2x plus 3 and g of x equals x squared. So to get f of negative g, f minus g of x rather, so we have 2x plus 3 minus x squared, and the answer will be negative x squared plus 2x plus 3. It is simple, just doing the operation of addition subtraction. Okay. Next, multiplication of functions. So again, given two functions, f of x and g of x, the product of these two functions is defined as f times g of x, okay, equals f of x times g of x. Example, given that we have 2x, f of x equals 2x plus 3 and g of x equals x squared. So the f times g of x will be 2x plus 3 times x squared, then distribute, okay, with the distribution. So the answer will be 2x cubed plus 3x squared. Next, so we have division of functions. Okay. Given that we have two functions here, the quotients of these two functions is defined as f over g of x equals f of x over g of x. For example, we have f of x equals 2x squared plus 3x, and our g of x is x squared. So to get the f over g of x, just simply substitute. Okay, we have 2x squared plus 3x over x squared. Then factor x, so cancel this one, so this will be 1. So the answer will be 2x plus 3 over x, or all over x. Last, so we have compositions of functions. Okay. Given that we have two functions here, f and g, okay, so this composition of two functions is defined as f of g of x. Yeah, f of g of x. So you can write it as this one. So what happened here is that given that you have g of x, okay, you will substitute this function to your f of x. Whatever is the okay, again, you have g of x, and the g of x will be substituted in our f of x, or in other words, so if you have x, let's say we have f of x, right? Okay. So all x here in f of x will be replaced by g of x. Right? G of x. So for example, here we have f of x equals 2x plus 3 and g of x equals x squared. So to find f of g of x, so all x of f will be replaced by g of x. And since g of x is x squared, so in short, x will be replaced by x squared. So we have 2 times x squared plus 3, and the answer will be 2x squared plus 3. Okay, so that's how you perform the operations and functions. So that will be all. Thank you, and have a nice day ahead.